guys, so today we're going to be looking at the AC sine wave. Firstly, you might ask yourself, what does AC stand for and how can we relate this to a sine wave? As you should all hopefully know, AC stands for alternating current. We know from Faraday's law that moving a conductor in a magnetic field will induce a current flow in the conductor. So if you look at a simple loop of wire rotating inside a magnetic field, a current will be generated. This is the simplest form of an AC generator. As shown in the video, interestingly enough, every half rotation of the coil will cause a current flow to switch direction. This is known as alternating current. Once we understand alternating current, we can then look at the mathematical representation of a sine wave and how we can relate this to the current and voltage produced by AC circuitry. The formula y as a function of t is equal to a sine omega t plus or minus phi is used to represent a sine wave. This is where a will equal our amplitude. Our amplitude is simply the maximum displacement from the mean average of the wave. It is both the same value in the positive and negative direction. Omega is equal to 2 pi times our frequency and simply represents the frequency of the wave in hertz. T is equal to our time in seconds. While finally we have our phase. Our phase can both be positive and negative. Firstly, we will look at a positive phase. Positive phase means that the wave is shifted to the left and will lead a wave without any phase. We can also have a negative phase. Conversely, this wave is shifted to the right and will lag a wave with no phase. The current and voltage of the AC circuit can then be represented as a function of time by the same formula, with the amplitude replaced by mean voltage and mean current. It is also important to note that one full cycle will equal our period t, which can then define our frequency, which is equal to 1 over t. Thank you for watching.